Well, good afternoon, everybody. This is Gene Bohensky with IR Thermal Systems. Thank you for coming today for our webinar presentation. The title of our presentation is Using Infrared Energy in Paint Finishing Applications of 3D Objects, Case Studies. And in this presentation, we're going to be sharing 5 of our case studies with extensive information on how we solved customer problems and application issues with IR energy and IR heating to cure various paint applications. And I think you're all going to like the presentation. So let's get started first with an introduction to the company. IR Thermal Systems was founded in 2020 after former management team purchased the assets and intellectual property of Radiant Energy Systems and Anderson Thermal Devices. The management team and the employees have had experience in the market since 1985, and we carry all that in our organization today. Our core competence is the design and manufacture of custom engineered process heating solutions for improving performance and lowering production costs. We focus on quality and dependability, constant investment in latest manufacturing technology. We also produce our own high-quality component parts. We primarily focus on continuous heating processes at our customers, and we're also technology independent, so that allows us the freedom to choose the best technology for the customer's application. So what is our main business is custom process heating solutions. You can see one in the slide here that we're showing. We do preheating, drying, and curing applications. We manufacture and service hot air systems, infrared systems, and heaters. And we also have combination hybrid infrared and hot air systems where the infrared portion is usually used as a booster. With these applications, we can increase line speeds, reduce energy costs, save space. We can solve application problems by leveling out uneven temperature or moisture across the web. And we can also easily heat selected zones across the web to improve quality. So we serve a wide variety of industries, including converting, paper, film, and foil, printing, nonwovens, plastics, adhesive lamination, batteries, which is becoming a hotter topic. We do a lot in the battery business, medical devices, filter media, fiberglass, advanced composites, industrial fabrics, automotive, packaging, wire and cable, textiles, and many other industries we work in. So how do we work with your team? We have a team of specialized engineers that review your existing process. We determine the best technology to use to meet your goals. With state-of-the-art design tools, we can develop a system tailored to meet your target specifications and also to solve your process problems. We also offer a low-cost infrared rental program that allows you to try our technology in your plant. And we'll talk about that a little bit later on in the presentation. So why should you choose IR heating in the first place? Well, there's a couple of main advantages that we'd like to make clear. Firstly, that infrared heating systems are more efficient in general, with lower energy requirements for the same results as standard hot air heaters or convection heaters. These energy savings costs can be significant, and more companies are installing this technology to be more green, as that's more of a topic today, and as energy costs rise. Energy is directly transferred from the heater to the target object for a higher heat transfer rate, and they're available in electric or gas-powered. Other infrared heater characteristics include that they're easy to zone for uniform heating of the product and width changes. There's a fast response time to changing process conditions, including quick startup and shutdown in most styles of heaters. There's also lower initial capital and installation costs, including floor space savings, because they take a lot less space for the same performance. And they're often added to existing conventional dryers to increase line speed and improve process quality, which is really our expertise as a company. So first of all, infrared is available in a number of different wavelengths. There's short wave, medium wave, and long wave heaters. Typically, the wavelength is dependent on the application requirement. Short wave emitters go from 2100 degrees to 4000 degrees Fahrenheit, and these are typically lamps that are installed in those applications. Medium wave emitters are 900 degrees to 2150, and we specialize in those. And also long wave emitters, 500 to 900 degrees, which is not really our specialty, but they do exist. So typically we choose the wavelength based on the application. And here we have a couple of graphs of absorption factors. To the left is one for water and the right for PVC sheet thickness. You could see that they have different wavelengths where the energy is absorbed, and we kind of tailor the wavelength that the IR systems work at to match these absorption factors. So with that introduction, I'd like to pass this over to our expert, Kurt Leach, who is going to start with our case studies, the first one being on IR powder coating. So Kurt, take it away.
Thank you. Thank you, Gene. This first application is a customer who reconditions parts when you're out at your local car repair shop. A lot of times you'll get involved with reconditioned brake calipers. In this case, once they've taken off all of the old surfacing by mechanical means, they powder coat them. And this particular customer runs a very high volume 3-shift operation. And before we got involved, they were requiring a 60-minute cure cycle in a 120-foot-long convection oven, meaning that they had to run only 2 feet a minute for the heavier parts, and they had to run 3 shifts. Well, what they had limited floor space, so they couldn't consider making the convection oven larger. And they definitely wanted to try to reduce the paint shop shifts to get it down to 1 shift. The answer was that we proposed this IR booster oven, which was placed directly in front of their existing convection oven. And this oven is 7 feet long, and it provided enough energy going into the parts to preheat them up to approximately 350 degrees Fahrenheit, and at least on the surface, and to actually begin to gel and flow out the powder coating. Next slide, please. This is what basically the booster oven looked like, and it provided the slot on the top to allow the parts to go through it, and it was self-contained. It was basically plug and play, which was very nice for the client. They were able to get this thing up and running over a weekend, and they were very appreciative of that. All pre-made on our floor. Next slide, please. To recap it, again, they were only running at 2 feet a minute and needed 3 shifts. They were really getting pounded by more sales demand, and they didn't have any room to expand, as mentioned previously. The result was that this oven allowed them we gave them a 60-second, roughly the new system ran at 7 feet per minute instead of 2. So they got more than 3 times the productivity, which did allow them to eventually eliminate 2 of the shifts. They were able to get down to 1 shift. The result was that they had a better quality coating. They eliminated some of the loss of powder from the convection oven from hitting the powder before it's gelled. And they found that by gelling and flowing out the powder quickly, they were able to get higher gloss readings, which was very important to this product. They They sold their standard, which was a black powder coating gloss, and then they had the ultra upgrade, which was a silver powder coating that really looked dynamite, being as shiny as it could. Big success. Next slide, please. There we go. Okay, this next company manufactures very heavy duty tool lockers and shop lockers for all kinds of purposes. This is again, it's a completely modular oven build that we were able to ship into the plant in one piece, have them drop power, have them drop the ductwork, and they were able to get this running in a relatively short period of time. There was not a lot of time required on the shop floor. This system not only consisted of our oven, but also a conveyorized, a track-mounted conveyorized system, which is coming up here. Next, there we go. Next slide, Gene. There we go. You can see here, this is what the lockers look like. These are 10 gauge. Oh, you can go back. There you go. They would enter the oven, and the oven itself was designed and it was zoned so that we could make sure that we had good uniformity around the perimeter of the part. Yeah, you can go to the next slide. Here you can see that the load area down here at the bottom would move, this conveyor moved along at about 2.5 feet a minute, okay? And our oven was a total of 30 feet with 4-foot vestibules on each end. So it was 22 feet of heat in the middle here. That meant that we were down around 9 or 10 minutes of the total heat cycle. They required 20 minutes of air dry before it got there. Otherwise, there would be too much water present, and the infrared oven could skin over and provide problems. This is a waterborne paint, and the biggest problem the customer had was that previously to this system, they had to wait 12 to 24 hours before they could pack out their products. So that meant they had to have the amount of floor space available to let these things sit overnight before they could pack them out and ship them. They utilized approximately 3,000 square feet for that. So the goal was that they had to let the parts sit before they could pack them out. Floor space was a premium, and they had some really bad situations where, you know, they have grinding and laser cutting in the shop that would cause them to have contamination on the surfaces overnight. By utilizing the combination of the oven and the conveyor system, it allowed us to take a batch process and convert it into a continuous process. The result was it took that entire drying cycle from 12 or 24 hours down to 1 hour, and it eliminated that bottleneck. They were able to convert this batch process so that they were able to produce a completely dried locker every 4 to 5 minutes. We were able to save them. This system only took up 1,600 square feet, so they got to save the balance, which in this case came out to about 1,800 square feet of savings. Obviously, the pack out let them invoice their customers a day earlier, at least, and that they were the improved surface quality from the elimination of any of the contaminants that would have normally settled on the parts during their air dry. So this was a real, you know, big success all the way around, and it's been running for over 10 years without any issues whatsoever. They're very happy with it. Next slide. This next one is very interesting. It's this is a company that manufactures bus mirrors. It includes the mirror frame, and of course the mounting framework and brackets. And they are very well entrenched in their market. They had a situation where they were utilizing a liquid paint that was not giving, it was an air dry, and it would not give the performance that their customers needed. The corrosion resistance wasn't up to what they would like to have had. This is obviously an automotive application, outdoor. So they had to upgrade their corrosion protection and to try to improve the finish quality and make it more rugged and durable. The result was that their plant was small, and we were able to quote them a 12-foot long oven that had 1.5-foot reflective vestibules on both ends. An overhead conveyor was manually indexed into position utilizing an 8-foot long rack of coated parts. By doing this, they were able to take some limited floor space and very limited electrical availability. That's why they preferred to go with natural gas. Also, it does have some advantages on cost of running. But the fact is that they were very limited on their connected load in their plant system. And this system was able to produce 4 8-foot racks per hour, which was sufficient to meet their demands. And it gave their customers a superior product to what they were buying. And again, the utilization of the gas avoided a costly upgrade to their overall infrastructure. Okay, so let's move on to the next one. This next one, we're all familiar with it because it involves something most of us have in our home, which is a hot water heater. This company also was going to go into a powder coating from a wet coating, and they were very high volume. They calculated, they knew what they were running the wet lines at, which was 40 feet a minute. So they were running a very high speed system. And if they were to stay with convection only to get the 25 to 30 minute cure cycle, they would have had to have almost 1,000 feet of conveyor serpentining back and forth inside of a 400-degree rated oven enclosure. They determined, and we with them, that by preheating the parts and gelling them, they could reduce that overall cycle rate dramatically. Matter of fact, I think we brought it down. We had 60 seconds of infrared exposure, and then they required another 4 minutes to get a full cure on the sheet metal. This is thin sheet metal. And one of the ways they did this is that these fixtures that you see in this photo, these rotated as they went through the infrared to ensure uniformity of all surfaces. So these fixtures were rotating slowly to make sure that, every surface got up to temperature and that the powder was gelling before it went into the convective portion of the oven. We sold them the infrared emitter banks that they mounted inside their oven, and it worked out quite well. Let's go to the next slide. Here you can see the emitter banks that we assembled in our shop, and they were shipped loose, stacked up like, partitions on pallets, and then the control panel that went with it. Next slide. So to recap, we were able to take a 30-minute cycle that would have required 1,000 feet of overhead conveyor and a very large amount of space for the oven, and reduce it down to basically 200 feet of conveyor that utilized our 39 feet of infrared inside to provide them with the ability to flow and then cure the powder coating on the surface. From what I know today, they are still running 3 shifts a day, and this has been going on since over a decade with no issues as far as we're aware of. And believe me, they are not shy about giving us a call if they had a problem. So we're very proud of this one also. Home run. Next slide. This one is a company that builds excavating equipment, very heavy, heavy steel. And once again, it is a booster oven. Let's go to the next slide and take a look at the variety of parts that they had to powder coat and process through the system. As you can see, there are weldments here utilizing 1/4 inch and even thicker. You got some castings and machine fabricated parts that normally would have required 70 to 90 minutes to cure. All right. And to do this would have required, again, a lot of overhead conveyor, a lot of capital expenditure. And they were aware of the fact that by utilizing infrared, we could reduce that overall footprint and reduce the overall time. In this case, I don't know exactly what the time was reduced to, but I am aware of the fact that they're very pleased with it. The oven module itself is 107 inches long, and we know that in the time that it took to go through that first infrared zone, that the powder was sintering, okay? It wasn't necessarily fully flowing, but it was stationary, it was fixed, so that as it went into the convection oven, the powder would not be in any way moved or blown away by the velocity of air that was inside the convection oven. Next slide, please. Here you can see that the gelling is taking place as it goes into the convection oven. And that's a large part. Not sure exactly what the weight on it is, but it's, believe me, that could be a counterweight even. But in any event, next slide. You know, to recap, again, the part profile size, I didn't mention that, is 72 inches wide by 90 inches high. This is a typo here, but it is 72 inches wide by 90 inches tall. So it was a large area, and we had a good wraparound, and we were able to drastically reduce that cure cycle down. In this particular case, the powder was being stabilized or sintered, as we call it, but the overall benefit at the end was not only to be able to run the cycle faster, but they did notice a higher degree of quality in terms of the smoothness and the gloss of the coatings. So that's another home run. So we are very proud of the fact that in general, if we were to summarize, where can infrared energy be of assistance in 3D finishing? We would say that number one, we can increase productivity. Two, there's a very good chance the finished quality can be increased also, because it is not going to have to require to have air being blown around. So we would design these specific ovens to meet the needs of the part shapes, you know, using the overall dimensions of the that the racks require. The results, I know it looks ridiculous, but sometimes we can increase the productivity by 10 times. The quality can be increased, and in many cases, the surface can be glossier. So I want to thank you all for coming out and spending the time with us to learn about this. And there will be some Q&A here a little later, and I look forward to hearing from you.
And I just wanted to just wrap up the presentation by letting everyone know that if you're interested in bringing infrared heating into your process, it's essential to run trials in a lab or your pilot line to confirm oven sizing and desired finish product quality, because there's a lot of things that you can tweak and look at depending on the coating or paint that you're using. I also want to state that we provide a rental heater program that we make available for our clients and customers to test out infrared in their own facilities. We have these available so that you can get them deployed very quickly.